So Bismillahirrahmanirrahim. In the third part of chapter 2, transformer, EP0244. So I'll explain a little bit on the phasor diagram. So as for the phasor diagram, usually you'll be asked to sketch phasor diagram of a transformer operating at certain power factor. Okay. So the following phasor diagram is for approximate equivalent circuit referred to secondary by using the KVL equation. So the KVL equation for referred to secondary is Vp over A equals to V. This is from the following KVL. Vp over A equals to Vs times Is R equivalent plus Is X equivalent S. The same thing. Just that we don't have N here because we just want to sketch, not accurately draw the phasor diagram. Yeah? Because N is just number. Okay. We are more interested in knowing the shape, the angle of your phasor. Okay. The phasor voltage Vs is assumed to be at angle of 0 degree. So we assume that Vs weighted is at 0 degree. Okay. So we have three possible power factor. Number one is unity power factor U1. Okay, where the theta is 0 degree. Okay. From where do I get theta 0 degree? Cos inverse 1 you get theta equal to 0. Number 2, lagging power factor I lags V. Before that, unity power factor, voltage at 0 we assume, and then current is at 0 also because the theta is 0. While for lagging power factor, voltage is at 0 while your current is below, or current lags your voltage, so your current should be down there lah, at angle of negative theta. For leading, voltage is Vs still at 0, but your Is leads voltage, so it is above Vs at angle of theta. Now, in this equation, we have three terms in order that we need to sum up in order to get your Vp over A. So the first term Vs is the easiest because it's always assumed at 0. So in all three cases, Vs is always at 0. See, Vs, Vs, Vs. Okay, first term settled. Second term is the multiplication of R equivalent, that is just number because it's real, no angle, but it has to be multiplied with Is. Is has magnitude, has angle, so this term will follow angle of Is. Okay. Now for unity power factor, your Is is at 0 also, so from Vs, the second term, that is R equivalent Is, is also at 0 degree. Okay, while for lagging, the second term, that is R equivalent Is, will follow exactly the same angle as your Is. So this theta equal to, if you have extrapolated dotted line here, equal to this theta. Okay, so Is parallel with Is R equivalent S, same angle. Okay, while for leading, Is leads V at theta, so Is R equivalent S also follows the same angle, or we can say that Is parallel with R equivalent Is. So number 2, term number 2 settled. The second term follows the angle of Is. But if you ask me why it is sketched shorter compared to Vs. Okay, so although it follows the angle of Is, but in terms of the length of the phasor, why it is shorter? So because R equivalent is, the value is quite small. So you multiply IS, that is also small value, with R equivalent, that is also small value. So that second phasor becomes shorter. It might be shorter than your IS, and it's definitely shorter from your VS. Okay. Third term is IS still follow angle of IS, but X equivalent has J. J is actually 1 at angle of 90. So if you multiply these two, this term, this third term will no longer follow the angle of IS. But how do we know the angle? Okay, see without the J, if you only have X equivalent times IS, it will follow exactly the same angle as the second term. But since we have J, you just need to perpendicularkan, or just find a phasor at 90 degrees from the previous term. Okay, in this case, the second term is R equivalent IS. Then because the third term times with J, so just take phasor 90 degree to R equivalent IS. So that will be your J X equivalent IS. Why it is pointed upward, not downward? Because the term is plus, plus. Right? So now you just draw a line from the starting point to the last or the third phasor, so you get your VP over A. Okay, while for lagging, okay, from the second term, find 90 degree to it. Okay, this is 90 degree perpendicular to R equivalent IS, and it's going upward because it's positive. So there you go, you have your VP over A. Okay, and then last one, leading. So this is the second term. So find a phasor at angle 90 degree to it. So it's going that way. This is 90 degree. Okay, so there you have your VP over A. So what can we extract from this phasor is that, okay, for refractive secondary, the formula for VR is VP over A, or the magnitude or the length of the phasor of VP over A minus magnitude of VS over magnitude of VS. So if the length of your VP over A is here is longer, the magnitude is higher than your VS, so your VR will be positive. So if you look carefully, VP over A for unity is longer than VS, so VRU positive. Same goes for lagging. VP over A is also longer compared to your VS, so your VR is still positive. Okay, big minus small, you will still have positive value. But for leading, the length of VP over A becomes shorter compared to your VS, so small minus big, you will be having negative VR. Okay, so if you calculate VR for a transformer that is operating at leading power factor, make sure you get negative answer. So the last part is the efficiency. Allahu Akbar. For the efficiency, okay, so generally the formula is PR over Pin times 100. But we know your Pin equals to Pout plus all your losses. Okay, so the losses considered to calculate efficiency, you have to Number 1 is copper loss, number 2 is core loss. Copper loss, core loss. Okay. So the formula for P out equals to the original formula is VSIS cos theta without 3 because your syllabus only covers single phase transformer. But again we have N here because your transformer can be operating at any condition, let it be full load or 50% operated load or 80% operated load, we don't know. So whenever you have IS, you must multiply it with N. So for P out, since we have one IS, so you only have one N here. Okay, now as for the losses, we have two types, copper and core. So okay, the formula for copper loss and core loss depends on which approximate equivalent circuit you are using. So if you are using reflector primary, so the copper loss is the losses at the R equivalent S. That is, we use the formula I squared R. Okay, so copper loss for reflector primary becomes the current is IS over A. So IS over A squared times R equivalent P. While for reflector secondary, the copper loss equals to IS times R equivalent, IS squared times R equivalent S. Okay. Now, if you look at the formula, we have IS inside the formula, right? So that's why for copper loss, and the current is squared. See? That's why for copper loss, okay, when we calculate copper loss, we have to multiply it with N squared because your current is also squared. Alright, moving on to core loss. Core loss is the losses at your RC. So if you're using reflector primary, since we don't know the current, we will be using formula for voltage for power, that is P equals to V squared over R, right? So core loss becomes VP squared over RCP. While for reflector secondary, the core loss becomes VP over A squared over RCS. And again, this VP over A comes from the KVL equation, yeah, that you have calculated earlier, not from the rated from the question. Okay, so for P core, why don't we have N for core? Because we didn't have the term IS here, but actually we have already included the N when you calculate the KVL. We have already inserted N in front of IS. Okay, so basically efficiency equal to P out over P out plus P core loss plus P copper loss. Alright, so how do we use those formula? So we continue our example 1, number 3 Roman. So now that we have calculated the voltage regulation, so the question asks you to determine the efficiency when it operates at 75% of its rated load. So efficiency, the formula is P out over P out plus P loss. So get your P out first. P out is N Vs Is cos theta. N is 0.5. Vs rated 2.2K from the question. Is rated from where? 45.45. We have already calculated it during the example for number 2 Roman here. Is rated you 45.45, angle of negative 30. So just take the magnitude, okay, times cos theta is your power factor 0.88. So that is your P out. Now you just have to calculate your copper loss and core loss. For copper loss, okay, for this question is using reflector primary, so the losses at R equivalent P lah, that is equal to IS over A squared times R equivalent P. So IS is 45.45, A is 5 times 3.25, so you get 268, and your P core is the losses here. So VP squared over RCP, but again this VP you cannot simply take from the question 11K, but get it from your KVL. Which KVL? From the second, the number 2 Roman question. You have to calculate VR, you need to use the VP from the KVL, right? So take the value of VP 11.05K, insert it 11.05K squared over 20K, so that is your P core. And then don't forget to multiply N squared with your copper loss. So your total loss now become 5 squared that should not be 5, yeah. Your N is 0.75, so 0.75 squared times 268.54 plus this, you get your losses, and you can count your efficiency. Okay, that's all. So betulkan ni, so make correction, this is N, yeah, N, yeah, that is 0.75, not 5. So I guess this example shows you how to calculate VR and efficiency by using reflector primary. So in the next video, I will show you the steps to calculate VR and efficiency as well, but if you are using reflector secondary, because the question may also ask you specifically by using reflector secondary calculate VR and efficiency. So you need to know both method, yeah. Other than that, this question asks you to find VR and efficiency at 75% of its rated load. So the question may ask you if find VR and efficiency at full load. Okay, so your N is 1. So in other words, you don't even need to multiply IS with N. Then it's fine, because you multiply anything with 1, you get the same answer. Okay, but it can also ask you to calculate VR efficiency at 50% of its rated load or 80% of its rated load. In that case, you need to include N in your IS. Hopefully you get the idea. I would like to apologize for any kekurangan, lacking or mistakes. Okay, hope you get the idea, insyaAllah. Okay, Assalamualaikum.